Hello everyone, my name is Khala and today I'll be presenting the parametric definition of the Chang Muslim Cultural Center. The project was completed in 2015 by Architecture, Design and Research Institute of SCUT and it's located in China. Moving on to the floor plan, the plan reveals that the building is made of 4 L-shaped volumes arranged around a central circular core, which is topped by a dome. Surrounding the structure is an exterior corridor framed by arches. Moving on to the main architecture components that I'll be creating is the dome structure and the roof elements, which includes the curved roof surrounding the dome and the flat roof that sits atop the L-shaped masses, as well as the facade arches and the exterior pattern. The dome consists of the outer dome surface and an internal space frame structure that sits above the dome panels that I'll be creating as well. So the first part of the definition is creating the L-shaped masses. I started with a big rectangle and then I used a scale battery to create the smaller rectangle, and then I used region difference to subtract it from the big rectangle. After that, I used the orient component to position multiple copies of the L-shaped mass around the base rectangle. Moving on to the roof elements, for the flat roof, I started by having a single rectangle and then I used polar array to copy it across the other sides of the base rectangle, and then I turned the surface into a mesh to run a kangaroo simulation using the bouncy solver, and the setup includes load, length and anchor goals. Finalize the flat roof, I use Weaverbird's mesh thicken and Weaverbird's mesh window to give it thickness. Moving on to the curved roof, I used ruled surface battery to create a surface from 2 curves, which is the inner circle and the outer rectangle. Turned it into a mesh to run a kangaroo simulation using the load, length and anchor. And then I used kangaroo diagonalize battery, Weaverbird's mesh frame, Weaverbird's mesh thicken and window. Moving on to the dome structure, I start by having a sphere. And then I used bounding box around the bottom half. And then I used cal battery to remove the bottom half, as well as to remove the top portion and create an oculus. For the dome panel, I start by having a rectangle, rotate it 45 degrees and use scale NU to change its size. I also used scale battery to create the outer frame of the panel. For the inner part of the panel, the curve was exploded. Use deconstruct point and evaluate that has x squared expression in order to create a smooth curve. The curve then is rotated, scale down, and use rolled surface and extrude battery to split it later. The same curve is used to create the inner surface so that the panel is not flat. The curve is moved down. So here is the final panel, but in order for the box morph to work seamlessly, I mirrored parts of the panel into the 4 corners of the box so that when morphing the panel into the dome, they fit together perfectly. So for the space frame, I'm offsetting the panel curve and using the closest point battery to get the center point, using evaluate surface and moving the point in the Z direction to create the diagonal members, and I'm using the same point to create the rest of the members as well. As for the diagonal members on the corners, I'm deconstructing the panel and moving the points to create the diagonal members on the corner. And here I'm using mirror and rotate as well as pipe. So here we have the final panel on top of the space frame, and we'll be morphing the panel with the dome. So for the facade arches, I have two curves from the ellipse component, and I loft between them. And then I used a box front face to split and create the final profile of the arch. As for the top part of the arch, I'm using arc 3 point to move the midpoint to the back and loft. And here is the final arch after extruding. And then I'm using divide length to orient the arches on the rectangle. And I'm using cull index to remove the extra arches from the entrance opening. As for the main entrances, I'm creating a line and then dividing it into points and using a graph mapper to create half of the arch and mirroring the point and turn it into a NURB curve. Then I'm using a rectangle to create the frame around the arch and using region difference. And then I'm using divide length to orient the 4 entrances on the base rectangle. And finally, for the wall pattern, I'm creating one rectangle tile and one arc and using divide to get the points and using list item to connect between the points. So here we have the pattern, and then I'm using orient to orient the pattern on all sides of the rectangle. And then I'm morphing the pattern on the walls of the almases. Here is the final pattern after extruding it.